I'm my topic is acoustic features for music emotion recognition systems. I will call it MER later. My motivation to study this topic is I think it's obvious that the strong connection between music and emotion is quite an attractive and interesting topic. I know a lot of us are also studying the emotional or music something about this topic. So I will leave my motivation in details, not that much detail. First, let's say something about the MER system. So basically, MER system try to maps music to emotions, to add labels or tags for that music. But how should we do that? We narrow down to their representations, because music and emotion can be quite subjective and sometimes not quite clear how you define them. Usually the current MER systems represent the music use some features like the lyrics, audio features, also like context information like social text and web document. For the representation of emotion, there are basically two types of models. One is for categorization, like this is a happy song, that is a sad song. There are also like dimensional representations, like how much degree you have in the, like for example in the happy, how much happy it is. That's the basic concept for the dimensional model. And then we have those music represented in features. We have the emotion represented in models. We use machine learning techniques to do classification or regression tasks to map those features to the models. And then we get the music emotion recognition done. This is a quite huge system. What I might focus on is the audio features, because I think the features are the first thing you need to consider when you want to do music emotion recognition. And also among all of those features, the audio features, namely the acoustic features, are the most studied topic. That's why I focus on this topic. So about the acoustic features, there has been a lot of studies to address this problem. So we can see there is already a lot of features studied by far. And for those studies, there are three types of study for the acoustic feature. First is to identify the informative features. Which like some features are more informative, some features can be more effective when they do those prediction. And another type of study is to identify informative feature sets or combinations, because researchers start to realize there are no dominant feature, like the most effective ones, there are none. The best results are always achieved by combinations of features. And the third type is the informative features with regard to different emotions or different instruments or different machine learning models. Like we can see earlier, there are so many factors in this system, so the features performance depend on what kind of models, what kind of classification or machine learning techniques you choose. From all of those studies, we can generally get some conclusion. First, like I already mentioned before, there are no dominant feature. The best results are achieved by the combinations. Second, you can see through all of those studies, usually those features are more popular. On one hand, I think it's because those are already proven to be more informative. On the other hand, I think it's because they are limited by the available data sets, because there are a lot of available data sets. They only provide those features for you to do your research. That's why those become more and more popular. The third conclusion I get is the MER systems usually use a bag of feature strategy. because you don't know or in your head like what kind of features might be best for my system. So you just stack all of those features together, and then you use some feature selection algorithm like SFS and PC to reduce the dimension in your feature set, and then you get the perfect feature set for your specific task. But those are but those studies are mostly for the overall music emotion recognition, namely you define the emotion of the music as a whole, like this music, the whole song is a happy one. But recently there is a trend for time-varying music emotion recognition, because people think the nature of music is actually is being dynamic. You cannot just define a whole song as happy. There might be some sad feelings between the music. And another reason is, according to some psychological research, the time plays an important role in music cognition process. Sorry for the missing part. It's like the human brain when you're processing those music to generate your emotions. The time plays an important part, namely the memory and expectancy. You raise the former emotions you already have. Somehow depends on how you perceive those emotions at current time. That's why there's a trend for the emotion tracking or time-varying MER systems. This is an example system, example study. They're using a Kalman filter to try to explore the potential for time-varying MER systems. But back to my focus, the acoustic features for time-varying MER. We can see there are not a lot of research has been done to address the informative time-varying features. I only found like 2 or 3 researches done to like this. They only studied NFC and chromogram, spectral, and contrast. They only studied those 4 features to evaluate which one is more informative in time-varying MER. But that's not enough. I think most of the researchers related to emotion tracking tasks, they are more focused on the classification models, or no, regression models, or the emotion representation models, because they just assume that those features which are informative for the overall MER systems are also informative for time-varying MER systems. Because there are strong connection between them, but no one has ever validated that, whether that's the truth, whether you can just directly choose those features from overall MER systems. The reason I doubt the current approach to select those features is, first of all, some poorly performed features for overall MER, they might have a better chance in time-varying MER. You cannot just neglect their effect. Another reason is some features in overall MER systems, they are calculated in a wrong way, because they didn't consider the fluctuations between them. They just calculated the whole statistics as the music goes on. But in time-varying MER, you really need to care about what these features are at the current time. So maybe MER systems, those non-time-varying features which are calculated wrongly in the overall MER can also have a better chance in time-varying MER. Yeah, that's basically what I studied for my survey paper, and look forward for the future work for time-varying MER. The first thing I want to mention is a lot of researchers see MER system as the ultimate goal of the whole MER systems, because they believe the time-varying approach can increase the precision of the music recognition, recognition. Also, the time-varying approach can relate to listeners' expectancy and memory, as we already mentioned before, for the music cognition process. A third reason is the time-varying ammeter can be more applied in the detailed emotion for music recommendation, because sometimes you don't only want a happy song, you want a song which is at first happy and then grows sadly, and at last it is excited again. That's why the time-varying approach can be used in this situation, but also there are more applications. The second thing I want to address for my survey is the informative feature identification for time varying is missing. Like I said before, researchers take it for granted to choose those features for overall MER systems. The third feature work I'm proposing here is more temporally aware machine learning techniques. Actually, there are a lot of researches already done in this part. They studied like conditional random fields, recurrent neural networks, but there are a lot more can be done to address this problem. And another future work I think have potential is the more problem appropriate feature vector, because some researchers propose in order to reflect the variations of those features, you cannot just use the absolute values of those features. You should represent those features in a relative values, like how much this feature is bigger or larger than the average values. And they believe by doing that, they can reflect those variations. Yeah, that's basically my presentation. Thank you.